Unit 3A, question number 15. This expression is to be the left-hand side of the equation that is an identity. Which of the following could be used as the right-hand side of the equation to complete the identity? I'm going to be looking at this identity, and this as I'm doing the problem, and basically I'm going to look for the end in mind. So I'm going to start with this side, and I have to make it look like one of these three. So let's see how I can do that. On the top, I'm starting to see a pattern that I have a 3 that I can factor out of everything. And so the first thing I'm going to do is simplify the bottom. And I see I can turn this 3 cotangent square of theta plus the square root of 9. I see that the square root of 9 is really a 3. So what I'm going to do is I'm going to factor out a 3 from the top and from the bottom expression, and I'm going to get 3 cosecant of theta. I kind of dropped my theta on that first one, and if you do that in the test, that's fine also, minus sine of theta, and I'm going to have this on the top. And on the bottom, I'm going to factor out this 3, so then I have this cotangent squared of theta plus 1. And if I do that, I see that this is one of my identities that is on my identity card. So, and I can also then cancel out my 3, so I'm starting to get a little bit more simplified. And I see that I have the cosecant of theta minus sine of theta all over. And I'm going to change this into my identity. It is going to be the cosecant squared of theta. So this all, I know that this all goes to the cosecant squared of theta. And when I now come back and I look at these at the top, I'm pretty much going to eliminate this one because I see that it says secant squared theta on the bottom, and so I know it can't be that one. I also look at this one and I see that there's a plus here, but I have a minus right here, so I am thinking that it can't be this one either. So what I'm going to do is, if I want to think with the end in mind, I'm going to see if I can set my equation equal to this one, because I pretty much eliminated this one and this one. All right, so let's see what our second step could be. The next thing that I tell you is in about 90 to 80 to 90% when I'm trying to prove an identity, I'm going to change everything into sine and cosine, and I really need a cosine here if I'm going to make this one work. So that's what I'm going to do. And I know that cosecant is 1 over sine theta minus sine theta. It's already in terms of sine, so I'm going to keep it. And then this cosecant on the bottom I'm going to turn into 1 over sine squared theta. And I'm starting to see this squared and a squared here. This might work. So let's see first if I can simplify this expression a little bit more. So the first thing I'm going to do is trying to get the top to be a little bit more together. And I see that if I want to combine the top together, I'm going to need to get a common denominator. And so I'm going to multiply this by sine of theta over sine of theta. And this is going to help me get a common denominator on the top where I can combine those terms. And this is going to end up being then on the top, I will have 1 minus sine squared theta. On the bottom of the top part, I would then have a sine theta. And I'm starting to really like this because I know that 1 minus sine squared theta I can turn into cosine squared theta. But I still have to worry about this complex fraction because on the bottom I still have 1 over sine squared theta. Okay, so now I'm going to look at the top, and I see that I can actually change this 1 minus sine squared theta into cosine squared theta, which this is starting to look really good. So I'm going to turn this into cosine squared theta all over sine theta, and this is going to be all over 1 over sine squared theta. And now I'm going to get rid of the complex fraction. I'm going to multiply the bottom by sine squared theta over 1. And if I do that to the bottom, I have to do that to the top. So I'm going to then multiply the top by sine squared theta over 1. And when I do that, I am going to cancel out. This whole bottom goes to 1. And so on the bottom, I have this sign canceled, and I have 1 left on top. So now I'm going to be equal to cosine squared theta sine theta. And I see that this does indeed equal this. And I can say that my identity on the right-hand side, I was trying to prove that it was equal to number 2.